This question is a little bit different from something we've done before. We have a piece of sheet metal that is 24 centimeters wide. We're bending up the edges, the outside pieces, to form a chute. Now, that chute, we want to have a rectangular cross section to have a maximum area. So in this case here, I'm not given an answer, so I don't have an isolating equation. So let's draw a picture of what this might look like. So I have this sheet of metal, and all the way across measures 24 centimeters. And these dotted lines are going to be the fold lines. So I want you to imagine that we're going to fold it up a length of x and a length of x on either side. So when I fold that up on either side, it's going to, here's the little cross section, it's going to form a little chute like that. So I know, since I'm folding it up a dimension of x, that the height of this is going to be x, and the length is going to be 24. Take away what I folded up, take away what I folded up, which is 24 minus 2x. So I want to have the maximum cross-sectional area. So I want my maximum area, length times width, to be, looking at this here, the length is 24 minus 2x, and the width is just x. So distributive property, I have a maximum area to be 24x minus 2x squared, or writing it with my x squared first, negative 2x squared plus 24x. So before I can complete the square, we need to factor the negative 2 out. So I have negative 2x squared divided by negative 2, which is just x squared. 24x divided by negative 2 is negative 12x, and then close my bracket. So using my grid here, I take x squared, I take negative 12x, and divide it into two equal pieces. So GCF of this row will be x, GCF of this column would be x. Take out the leading coefficient and the other leading coefficient, and let's check to see if we did that right. X times x is x squared, negative 6 times x, negative 6x. X times negative 6 is negative 6x, and negative 6 times negative 6 is positive 36. So inside the brackets, I'm going to add 36 and subtract 36. The reason I do that is because 36 take away 36 is 0, and I can add 0 to any expression without changing its value. So let's factor the perfect square trinomial, which is right there. And looking at my grid, I can see it factors as x minus 6 times x minus 6, or x minus 6 all squared. On the outside, I have to account for this negative 36, but it's not negative 36, it's negative 2 times negative 36, which I need to take out. So negative 2 times negative 36 is positive 72. So now that I've completed the square, let's state our vertex. Opposite on the inside, straight up on the outside. Because my leading coefficient is negative, I have a parabola that opens down, which means it does in fact have a max. So this is what my max is. This is when my max is. So what my max is a maximum area, and that maximum area is 72 centimeters squared. Let's just double check that my units are centimeters. Yes, they are. Okay. And when it happens, well, that's the x, that's the amount that I'm going to be folding off. It happens when x is equal to 6 centimeters. So let's go up here and see what the dimensions are. The dimensions were x by 24 minus 2x. So 24 minus 2x. We just found that x was 6. So 24 minus 12 is 12. So if I have a rectangular chute that measures 6 centimeters by 12 centimeters, it will have a maximum area of 72. So let's look at this, see if we answered the question. So altogether it says find the dimensions, that's this, that will give a maximum cross-sectional area, and that's this. So I know I've done my question correctly.